This video has two major topics to it. The first one is to use graphs in order to solve inequalities, and the second one is to look at an introduction to substitution as a solution to systems of equations. So let's start about taking a look at these two graphs, the red one and the green one. You always want, when you're looking at these graphs, to look where the graphs intersect. So when we look at this, notice that these intersect at x equals -3 and x equals 1. Those are the two key points in order to talk about the graph. Now, if we want to talk about when the red function, this linear equation, is greater than the green function, the quadratic, the parabola, we look at these two and we see that red is above, notice green, that's what we're looking at any x value, green is above over here, red is above in between these 2 points. So you see that at this x value here, we've got red above green. So we look at that and say from -3 to 1, we've got red above the green. Now when we're looking at the green above the red, so red below the green, then you look at any point out here, red's below green out in this area, and red's below green out in this area for any x value. So to describe those intervals, it goes all the way from -infinity to -3, and then the other part is starting at 1 and then going off to infinity for the other interval that it goes with the red below the green. Now let's look at some examples of how we can use the graphs in order to solve an inequality. We've got an absolute value here. We're going to talk about this graph by looking at what the graph looks like and then comparing it to 0, which is the x-axis. Okay, so let's go ahead and graph this. Now this tells us that we're going to shift the absolute value over 5 units. So 1, 2, 3, 4, 5. And then we're going to shift it down 2 units, so down to -2. So this is the vertex of our V. And then if you were to graph it, it would go through here at 7, and then also through here at 3. Those are the two key points where the x-axis and this V, or this absolute value graph, would intersect. So that's going to help us because we're going to look for when is the absolute value graph, the V, above, because we're greater than or equal to, above or equal to the x-axis. Well, it comes from -infinity, where you've got this graph above, all the way to 3. Now on this one, we're going to include the 3 because it's or equal to. It could equal the other graph. The other interval starts at 7. Now since it's or equal to, they match there at 7. So we're going to include it. And then it goes off to infinity, where the purple graph, this absolute value graph, is above it or equal to it. So if you have the or equal to, make sure you use the bracket to include it. Let's do this one. We're going to graph these two separate ones here. So if I graph, let's go ahead and set up a grid. So here's -5. So on this one, I'm going to start my graph at -5, 1, 2, 3, 4, 5. And then I'm going to go forward, I'm going to go up 4, 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1, draw the graph. Okay, and so that's my graph. It's a little crooked, but you get the idea of that linear equation. Now let's graph y equals the opposite of x, the second one. Start that one at a y-intercept of 0. Then we're going to go down 1 over 1. There's my intersection point, down 1 over 1. And draw this graph. So we want to know when this graph here, let me highlight the first one here in green, just so we can see it here. Okay, this one is in green, so we can see that this graph, when is the green graph below the purple graph? So that anytime we look over here, notice over in this section, green's below purple on any x value. Here, green's above purple. So we want this area over here from negative infinity, and then we're going to go all the way to this point of intersection where x equals 1 and end at 1. Now, do we include the 1? It's just a less than, so we don't actually include the 1. So that's how you can do an inequality. If you're given an inequality, graph both sides of them, and then decide which graph is above the other according to it, and come up with the interval that it works. All right, now let's take a look now at substitution. We're going to solve systems. Just a reminder, a system of equations is two or more equations, and the solution to it, in this case, because we've got x's and y's, the solution is the ordered pairs that work in all equations in the system. So that's our goal, is to find those. Now we want to come up with some steps for doing substitution. You're probably familiar with this, so this will come fairly quickly. But just to be organized, we want to make sure that when we solve these, we get one variable by itself. Sometimes it's already by itself, but we want to either get x equal to everything on the other side, or y equal to everything on the other side, or whatever variables you're using in the system. Substitute into the other equation. And then the third step is you want to solve and then repeat the process. Okay, let's do an example. For this, here's our example. Notice that you want to get one of the variables by itself. This one's already by itself, so that's the one I'm going to use. But you could, in the second one, it would be easy to get x by itself by subtracting 2y from both sides. So let's go ahead and we're going to take this 3x plus 10 and we're going to substitute it in the second equation for the y. Y comes out, the 3x plus 10 goes in its place. So we're going to have x plus 2 times, and instead of y, we're going to have a 3x plus 10 equal to negative 1. Now we're going to just solve that equation. So go ahead and distribute through the 2. So you have 6x plus 20 equals negative 1. X plus the 6x is 7x. Now we're going to subtract 20 from both sides. So you get negative 21. Divide by 7 on both sides, and you get x equal to negative 3. So that's our x value. Now we're not done. We need both the x and the y. This is where you repeat. We're going to take what we know, the negative 3, and put it back into either one of the equations. You can pick. I'm going to do it the second. It's probably easier in the first, but we're going to pick the second just to show it works in either. So you put negative 3 in for x. So I get negative 3. Put a little arrow here, so we know that's what we're substituting. Plus 2y equal to -1. So I'm picking the first equation, x plus 2y equals -1. Substitute in the 3. Now go ahead and add 3 to both sides. 2y is equal to positive 2. And then we go ahead and divide by 2, you get y equal to 1. So our solution should be the ordered pair, -3, 1. Let's check it to make sure. If you put a -3 in for x here, -3 times 3 is not -9, plus 10 is equal to 1. And we figured out by putting it into this one, it works here, -3 plus 2 is also equal to -1. So the first thing we did was we solved inequalities by graphing both and using the graph to see which graph was above the other or below the other to solve the inequality, looking at the intersection points to help determine the intervals. And then second, we looked at substitution. We went ahead and took our system of equations, got one variable by itself, substituted into the other equation, solved, and then repeated to find the solution for our system of equations.